Section 7.2 is on sample proportions. We've already introduced sample proportions and sample means in a sampling distribution, and we know now what a sampling distribution is. In this section, we'll look at the mean and standard deviation of the sampling distribution of a sample proportion, determine whether or not it is appropriate to use the normal approximation to calculate probabilities involving the sample proportion, and we'll calculate probabilities involving the sample proportion. Lastly, evaluating a claim about a sample proportion using the sampling distribution of the sample proportion. How good is the statistic p hat as an estimate of the parameter p? The sampling distribution of p hat answers the question. Consider the approximate sampling distributions generated by a simple random sample of the Reese's Pieces drawn from a population whose proportion of orange candies is either 0.45 or 0.15. What do you notice about the shape, center, and spread of each? As you can see, the sampling proportion changes very much with the shape, center, and spread of the data based on whether the proportion is either 0.45 or 0.15. Here's what you should notice about the shape, center, and spread of a sampling distribution. Shape. In some cases, the sampling distribution of p hat can approximately be looked at by a normal curve. This seems to be dependent upon the sample size n and the population proportion p. Center. The mean of the distribution, mu of p hat, is equal to p. This makes sense because the sample proportion p hat is an unbiased estimator of p. Spread. For a specific value of p, the standard deviation of sigma of p hat gets smaller as n gets larger. The value of sigma of p hat depends on both n and p. There is an important connection between the sample proportion p hat and the number of successes in the sample. P hat equals the count of successes in the sample over the size of the sample, which is equal to x over n. In chapter 6, we learned the mean and standard deviation of a binomial random variable x. Our mu of x equals n times p. Standard deviation, or sigma of x, equals square root of np times 1 minus p. Since we are multiplying the random variable by a constant to get the random variable, we get mu of p hat equals 1 over n times np, which simplifies to simply p. P hat is an unbiased estimator of p. The standard deviation is going to, again, the n's will cancel when we multiply by 1 over n inside the parentheses, so we get p times 1 over p over n, all under the square root sign. So as sample size increases, remember that the spread decreases. Before you perform normal calculations, you have to check the normal condition. Is n times p greater than or equal to 10 and n times 1 minus p greater than or equal to 10? We can summarize the facts about the sampling distribution of p hat as follows. Choosing a simple random sample of size n from a population of size of capital N with proportion p of successes, let p hat be the sample proportion of successes. Then, the mean of the sampling distribution, p hat, is equal to mu of p hat, which equals p, the parameter. The standard deviation of the sampling distribution of p hat is the square root of p times 1 minus p over n, as long as the 10% condition is satisfied. So remember, that means that you have to have n less than or equal to 1/10 of the population. As n increases, the sampling distribution becomes approximately normal. Before you perform it, you have to check the normal condition, np greater than or equal to 10, n times 1 minus p greater than or equal to 10. We can summarize the facts about the sampling distribution of p hat as follows. Population proportion p of successes. We take a simple random sample of size n repeatedly, which are the p hat values. We then take the values of p hat and put them onto what hopefully will end up looking like a normal distribution curve, where mean is the same as the mean of the population proportion p if it's an unbiased estimator, and the standard deviation is p times 1 minus p over n, all under this square root sign. Inference about a population proportion p is based on the sampling distribution of p hat. When the sample size is large enough for np and n times 1 minus p to both be at least 10, the normal condition, the sample distribution of p hat is approximately normal. A polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. Suppose 35% of all first-year students actually attend college within 50 miles of home. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value? First, we state the question. We want to find the probability that the sample proportion falls between 0.33 and 0.37, which is within 2 percentage points of 0.35, which was the 35%. Our plan. We have a simple random sample of n equals 1,500 drawn from a population in which the proportion p equals 0.35 or 35% attend college within 50 miles of home. In our plan, we know that mu of p hat is equal to 0.35, and that sigma of p hat will equal 0.35 times 0.65, this is p times 1 minus p over n, which is 1,500. That equals, after we take the square root of that all, 0.0123. Since np is 1,500 times 0.35, or 525, and 1,500 times 0.65, which is n times 1 minus p, is 975, they're both greater than 10, we'll standardize and use Table A to get the desired probability. Find the z-scores. Take the value 0.33 minus 0.35 divided by the standard deviation. Remember that this 0.33 is because we want it to fall between 0.33 and 0.37 in the problem. Standardize that. Z equals negative 1.63. Do the same for 0.37. Get our z-scores for those. So we're finding the probability that p hat is between 0.33 and 0.37. We then find where z is between negative 1.63 and 0.163. So we take, remember, the amount of the probability here on a standard normal curve, which is 0.9484, and we're going to subtract the piece right here that I don't want, which is the probability z is less than negative 1.63, that's the 0.0516. That will give us the amount of space or probability in between the two values. We get 0.8968, which our conclusion is about 90% of all simple random samples will give a result within 2 percentage points of the truth about the population. Here's another example. The superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a 4-year college or university. Suppose 80% of all middle school students in her district are planning to attend a 4-year college or university. What is the probability that a simple random sample of size 125 will give a result within 7 percentage points of the true value? First, we state the question. We want to find the probability that the proportion of middle school students who plan to attend a 4-year college or university falls within 73 and 87% because we take 80 minus 7 and 80 plus 7%. Therefore, we're finding the probability p hat is between 0.73 and 0.87. Here's our plan. Mu of p hat is 0.80. Because the school district is large, we can assume there are more than 1,250 middle school students. So our standard deviation, we take 0.80 times 0.20, that's the p times 1 minus p, over 125, which is the simple random sample size of 125. We end up with it equal to, when we take the square root, 0.036. We can consider that the distribution of p hat to be approximately normal since n times p is 100, which is greater than 10, and n times 1 minus p is 25, which is greater than 10. We do the distribution. On the last one, I showed you using, that would be looking up on the A table, just a basic calculation. On the second example, here's a review of using the graphing calculator to find the normal distribution. If you want to use the distribution curve values from a calculator, again, use normal CDF, and that would be to be between 0.73 and 0.87. We put in normal CDF 0.73, 0.87, then we put in our p, which is 0.80, and then 0.036, which is the standard deviation. So this is the sample mean, this is the population proportion mean, this is the population proportion standard deviation. So our answer is 0.948. And here's a note: to get full credit when using normal CDF on an AP exam question, students must explicitly state the mean and standard deviation of the distribution as in the plan step above, meaning you have to show these two values. Conclusion: about 95%, so this is 94.8 or 95% of all simple random samples of size 125 will give you a sample proportion within 7 percentage points of the true proportion of middle school students who are planning to attend a four-year college or university. This is our conclusion of lesson from Chapter 7, Section 2. Here's a summary of what we've learned today. In our next lesson, we'll learn how to describe and use the sampling distribution for sample means.